Hello and welcome to this solution video. If you like this effort of mine, please give it a thumbs up, share with your friends and subscribe to Math United. Let's start with question number 1. The polynomial 4x cubed plus ax squared plus 5x plus b, where a and b are constants, they are denoted as px, 2x plus 1 is a factor, and when divided by x minus 4, the remainder is 3 times when divided by x minus 2. Find a and b. So a very straightforward polynomial where we have to use remainder theorem. Since 2x plus 1 is a factor, that means if 2x plus is 0, px will also be 0. If it is a factor, right? Any factor that multiplies a polynomial, that polynomial also becomes 0 if this is 0. So let me write here if. So 2x is equal to minus 1 in this case, and x is equal to minus 1 over 2. And that means p of minus half is equal to 0 because it's a factor and the remainder will be 0. So let me substitute this minus half into the main polynomial. So it will become 4 to the power minus half cube plus a minus half square plus 5 times minus half is n plus b is equal to 0, which gives me what? 1 over 8, negative 1 over 8. So if negative 1 over 8 multiplies with 4, it becomes minus 1 over 2. This is 1 over 4 multiplied by a, so it becomes a divided by 4. Then minus 5 over 2 plus b equal to 0. So since they have a denominator here and no denominator here, let's multiply the whole of it by 4. So that it gives us a proper relationship between a and b. So minus half times 4 is minus 2. A over 4 times 4, 4 and 4 cancel, so just a. Minus 5 over 2 times 4 will be minus 10 plus 4b equal to 0. So minus 2 and minus 10 becomes minus 12. So a plus 4b is equal to plus 12 when it comes to the right side, and this becomes our first equation. Now second time they're saying that when x minus 4 divides the polynomial, the remainder is 3 times when it is divided by x minus 2. So let's say when x minus 4 divided by remainder theorem, that means p4 is 3 times p 2. Yeah, because this x minus 4 will give me x equal to 4 just like that, and x minus 2 will give me 2, and this is whatever is left is remainder. It was 0 because it was a factor. So p4, let's substitute here. 4 cube plus a 4 square plus 5 times 4 plus b is equal to 3 times, and then we have 2 cube plus a 2 square plus 5 times 2 plus b. Okay, so this is 256, yeah, 256, then 16a plus 20 plus b equals to 2 cube is 8 times 4 is 32 times 3 is 96. A square is 4 times 3 is 12. A. 5 times 2 is 10 times 3 30. And then we have 3 times b, 3b. Okay, let's simplify this. So 16a is here, 12a is here, so 16a minus 12a is 4a. Then we have b here and 3b here will come to the left side, becomes minus 3b. So b minus 3b will be minus 2b equal to 96 plus 30 is 126 256 plus 20 is 276, but negative if it comes to the right side. So 4a minus 2b equals to negative 150. Since they are all even, so I can divide the whole of this by 2. I can multiply by 2 just like I did in previous part, multiply by 4. I can divide the whole equation by the same number again. So it becomes 2a minus b equal to negative 75. And we had something here, a plus 4b, this one. Let me use elimination. For elimination, I will multiply again this whole equation by 4 so that it becomes minus 4b, this one. So I'll multiply by 4. It becomes 8a, yeah, 2a times 4, 8a minus 4b equal to 300. This cancels. That was the purpose. 9a equal to 288. Yeah. And now a will be minus 288 divided by 9, which is minus 31832. Minus 32 is the value of a. They said find the value of a and b, so I can find b now. So I can find b from here. So 2 times 32 minus b is equal to minus 75. So I substituted in this equation the value of minus 32. Minus 64 minus b equal to minus 75. Minus b equal to negative 75 plus 64. Minus b is equal to negative 11. And b comes out to be 11. So we got b as well as a. Question number 2. It talks about a definite integral x square natural log 3x, and we have to give answer in this format where a and c are rational numbers, b is an integer. Okay, so let me rewrite this here. 1, 2, 3 x square natural log of 3x. Since it's a combination of a algebraic and a logarithmic part, we will follow this sequence where we have these two, logarithmic and algebraic. So whichever comes first is taken as the u, and this is algebraic part, which will be taken as v prime, the differentiation of some part, algebraic part of the expression. So it follows the product rule, which says that the integration of u v prime, that's what it is, right? u v prime is u v minus u prime v. Okay, so I have assumed that the logarithmic part is u, so let me write it here. Logarithmic part is natural log of 3x, that comes out to be u, and x square is the algebraic part, that comes out to be v prime, and that this will become u v prime, right? This one. So this has to be equal to u v, as according to our product rule, u v minus log of, not log of, integration of u prime v. So u is ready-made with us, natural log of 3x, so we'll write natural log of 3x. V is not with us, we have v prime, which is derivative, so we'll integrate these two. So integration of a differentiation is just v, and this will be x cube over 3. So this this v will be replaced by that I will write in front in place of the letter, so it will be x cube over 3 minus, we will have to differentiate u now, which is this. What is differentiation of natural log of 3? It is 1 over 3x multiplied by differentiation of 3x, which is 3. So 3 and 3 cancel, 1 over x. And v V is we just got it, x square over x cube over 3, x cube over 3. So now this x can cancel with one of them, it becomes x square and left with dx. So it is x cube over 3 natural log 3x minus, and we're left here with 2 over, no, x square over 3. So let me write 1 over 3 outside and x square dx here. Okay, so now this will be integrated easily now. So we are left with what? X cube over 3 natural log of 3x minus 1 over 3, and this will be x cube over 3 again plus c now, and it is from 1 to 3. That was the lower and upper limit given to us. Okay, so now let's substitute 3 here and we'll get the answer. So it will be 3 cube, which is 27 over 3 natural log of 9. Yeah, 3 times 3 will be 9, minus 1 over 9 x cube, 3 cube again, plus c. You write on, don't write c, doesn't matter because c will get cancelled out very soon. Now we'll substitute 1, which is 1 cube is 1 over 3 natural log 3 times 1 is 3, minus 1 over 9 1 over 1 cube and plus c. Okay. 27 over 3 is 9 natural log of 9, minus 27 over 9 is 3, then minus 1/3 natural log 3 minus 1/9. Okay, so they want not minus, it will be positive. Why? Because there is negative here and there is negative here also. So they want a natural log with a coefficient and then plus something. Okay, so let's do what? This is natural log 9, this is 3. So can I write this as 9 natural log 3 square? Then minus 1/3 natural log 3, then minus 3 and plus 1 over 9 will be minus 26 over 9. Now this 2 will come in front and becomes 18 natural log 3 minus 1/3 natural log 3 minus 26 over 9. Since both of them are natural log 3, so this becomes natural log 3 of what? 18 minus 1/3, which will be 54 minus 1, 53 over 3. And minus 26 over 9. This is what it is. A is this one, C is this one, and B is this one. Both are rational numbers, A and C. B is an integer. This is what they wanted us to show. Question number 3. The equation of a curve is natural log of x plus y equal to 3x square y. Find the gradient of the curve at the point 1, 0. Okay. Even if they had given one of them, 1 or 0, we could have found the second one by just substituting it here. Anyways, so we want the gradient only. The gradient is nothing but dy over dx. The change of y with respect to x is gradient. Okay, general rule for gradient, then we'll substitute 1, 0. Okay, let's differentiate this whole equation. So the differentiation of natural log x plus y will be 1 over x plus y multiplied by the differentiation of x plus y. So multiplied by differentiation of x is 1. Differentiation of y is also 1, but it will be multiplied by dy over dx because it is being differentiated with respect to x. Okay, then we have x square and y multiplying. We'll use product rule here. So 3 differentiate to x square plus, so 2x and y remains y, plus 3x x square remains x square. 3 is already taken out, right? The x square remains x square, but y is differentiated, which is dy over dx. And now our purpose is to find dy dx by combining or somehow bringing them together. So let's open this bracket. 1 multiplied by 1 over x plus y will be 1 over x plus y plus 1 over x plus y dy over dx equal to 6xy plus 3x square dy over dx. So 1 over x plus y and plus minus is plus right here. So minus 3x square, they both have dy over dx, so I take that common. Then 6x plus xy remains here minus 1 over x plus y, which comes from this left side. Alright, so dy over dx will be 6xy minus 1 over x plus y divided by 1 over x plus y minus 3x square. And now we know that the point is 1, 0, which means x is 1, y is 0. So dy over dx, because of that, becomes 6 times 1 times 0, 0, minus 1 over 1 plus 0, divided by 1 over 1 plus 0, minus 3, 1 square. I substituted 1 and 0 in this, which becomes minus 1 over 1, minus 1 over this 1, minus 3, which is minus 1 over minus 2, 1 over 2. Question number 4, we have to prove this identity first. So there's some ways, many ways of doing this. So let me do the easiest one I can see. I know that secant square theta is equal to 1 plus tan square theta, and this is what I'm going to use here. So secant to the power 4 can be written as secant square theta square. So I'm talking about left hand side here, minus tan to the power 4 theta. Now secant square theta can be replaced by 1 plus tan square theta minus tan to the power 4 theta. Now I can use the identity, oh sorry, I forgot to write square here. So I can use the identity a plus b whole square, which is a square plus b square plus 2ab, and that's what I'm going to use here. A square plus b square plus 2ab, and then we have minus tan 4 theta. Okay, 1 square is 1 plus tan to the power 4 theta plus 2 tan square theta minus tan to the power 4 theta. This and this will cancel out. What are we left with? 1 plus 2 tan square theta, and that is right hand side proved. Hence or otherwise solve the equation secant square 2 alpha. Look, this theta is replaced by 2 alpha, this theta is also replaced by 2 alpha. That means what we got here, we can substitute it here. 1 plus 2 tan square, 2 alpha can be written in place of the left hand side. So that's what I'm going to do now. Okay. 1 plus 2 tan square 2 alpha equal to 2 tan square 2 alpha secant square 2 alpha. Okay, now everything is tan square alpha. This secant square must go, and we know that secant square alpha 2 alpha will be equal to 1 plus tan square alpha. and that's what I'm going to do here. So 1 plus 2 tan square 2 alpha remains what it is, and 2 tan square alpha also remains what it is. The secant square will change. And let me open this bracket. So it will be 1 plus 2 tan square 2 alpha equal to 2 tan square 2 alpha times 1 will be this, then plus 2 tan to the power 4 2 alpha. Okay, so exactly same here, they get cancelled out. So 1 equal to 2 tan to the power 4 2 alpha. Let's bring this 2 here, so it becomes half equal to tan to the power 4 2 alpha. That means 2 alpha is tan inverse. Okay, first we should not do directly. We should find fourth root of this and fourth root of this, so that this goes. And it will not be only positive, it will be positive and negative both. So it will be positive or negative, not this side, yeah, here. So positive and negative fourth root of 1 over 2 equal to tan 2 alpha. So 2 alpha becomes tan inverse of fourth root of 1 over 2, and I have not written plus or minus in this case. Why? Because of this. They have given our alpha is between 0 to 180. So 2 alpha will be between 0 and 360, doubled, doubled and doubled. This is our domain for 2 alpha. And if I put a minus here, that is of no use, because tan inverse minus will give you only one angle. So what we do, we will find them in quadrant. So the positive one will be in this quadrant and this quadrant from 0 to 0 to 360 degrees, and negative in this quadrant and this quadrant. All four quadrants will have an answer. So tan inverse positive 1/2 will give us these acute angles with the horizontal line, these four acute angles. So there is no need for negative, it has already given us quadrants. Okay, so now let me find what is tan inverse fourth root of 1 over 2 alpha. It comes out to be about 40.06, 40.1. Yeah. All right. So this is 40.06. Oh, sorry, 40.1. Let's make it 40.1, 40.1, and 40.1. So our answers start coming now. The first answer will be this angle, which is 40.1 itself. So 2 alpha equal to 40.1. So alpha comes out to be 40.1 over 2, which is 20.05. Okay, I think 20.05. So 20.1 we can write. Okay, around this. The marking scheme is not out. So if it is 20 or 20.1, that's fine. I'm doing it mentally now. Second angle, from 0 degree, the second line, which is this one. It is 180 minus 40.1. That is 2 alpha. So alpha equals to 180 minus 40.1 divided by 2. So it will be about 140 divided by 2, 70 degrees. So first one you can write 20.1 or 20.1 degrees or 20 degrees, depending on how many degrees you get in a calculator. So here we can write 70.0 degrees. Okay. Third, starts from 0, goes and stops in third line here, which is 180 plus 40.1. So alpha will be 180 plus 40.1 divided by 2, which is 220 divided by 2, 110 degrees. And finally we have the fourth angle, which is starting from 0 till this line, which is 360 minus 40. So alpha will be 360 minus 40.1 divided by 2, 320, 160, about 160 degrees. Question number 5, A part says, by sketching suitable pair of graphs, show that equation this has only one root. So what will I do? I will make the left hand side one function and right hand side one function. That makes it suitable pair of graphs. So I broke the equation into two parts. So this is y equal to 2 plus, let me write it this way, e to the power minus 0.2x plus 2. Yeah. Second one, the right hand side will become y equal to natural log of 1 plus x. All right. So I'm using the logic. You can use algebra. How to use algebra, I'll tell you later. First, let me use logic. So e to the power x first. What is the graph of e to the power x? Simple, this way, which passes through 1. Okay. Now we have 0.2 in front of it. 0.2 means it is horizontally stretched by 5 times. That means this graph will become little stretched. Okay. Now there is a minus. Minus means it will be reflected on y-axis. So your graph will be this. And then finally this plus 2 will take this graph up. So it is usually passing through 1. It will pass through 3. And that's what I'm going to draw here. 1, 2, 3. And this is my knowledge of graphs. That's what I'm using here. Okay. That's the first part. E to the power minus 0.2x plus 2. Second graph has to be natural log 1 plus x. So natural log graph is like this. But this plus 1 will shift it, translate it to the left side. That means this graph will actually pass through 0 now, and that will be the graph, and asymptote will be this, x equal to minus 1 will be the asymptote. So that's what I'm going to draw. I will draw this from here, and there's no need to draw it beyond, but if you want to draw it, that's what it will be. Minus 1 is the asymptote. So these two graphs are crossing at one place. That's what it's saying. By sketching suitable pair of graphs, I've done that. Show that the equation this and this has only one root. Yes, it's going up, it's going down, so they will never cross it again. So we have just one root where they are crossing, point of intersection. Okay. Now, show by calculation now. That was by graph, this was by calculation, that this answer is between 8 and 9. 8 and 9. Somewhere here in between, you have this answer. Okay. And how do we do that? For that, we simply collect all the terms to one side first. So 2 plus e to the power minus 0.2x minus natural log of 1 plus x equal to 0. So the one which was on right side also goes to the left side, and we are left with 0. Since it is equal to 0, and they're asking us to prove that it is between 7 and 9, the root that makes it 0 is between 7 and 9. So if I substitute 7 and 9 one by one of them should be some sign, and one of the other one should be the opposite sign, because the root always passes through x-axis, right? So if this is positive, it will become negative after the root, or if it was negative, it will become positive after the root. So that's what I'm going to do. I'm substituting 7 and 9 one by one. So when x is equal to 7, what do we get? 2 plus e to the power minus 0.2x, not x, 7. In place of x, we'll write 7, minus natural log of 1 plus 7, 8. Right? And we'll see what amount it gives us. By the time I use my calculator and find this out, I would request you to like this video, share with your friends, and subscribe to Math United. Okay, what I'm getting here is 0.1672. And I will substitute when x is 9. E to the power minus 0.2 times 9 minus natural log of 9 plus 1, 10. And that comes out to be negative 0.1373 and more digits. I am not interested in the value. I'm interested in the sign. There is positive here, negative here. So we can write that the presence or change in sign. Change of sign indicates the presence of root between x equal to 7 and x equal to 9. That this statement is very important because this plus is changing to minus, that is showing that the 0 is in between, that is our root between 7 and 9. Let's go to second part of the same question. Now they're asking us to use iterations, okay? So let me make it a little bigger and remove the other one. Okay. Now we have to use iterative formula, this one, correct to 2 decimal places and 4 decimal place iterations every time. Here they have given a new particular notation, which is expx is an alternative of e to power x. That means exp bracket something, this is power to the e to the power. So what it means that xn plus 1 is equal to e to the power, whatever is inside the bracket is the power. So 2 plus e to the power minus 0.2x, and now bracket closes, that means minus 1 will be the main number. Okay, just keep in mind, to make it less complicated they have written exp. Okay, now we have to start with x2 because x1 will be between 7 and 9 they said, right? So let's start with 8. And we will substitute 8 in place of x in each iteration. So let me write here e to the power 2 plus e to the power minus 0.28 minus 1. Okay, and after this I'm fastening this video. It will be fast forward and you will see all the iterations at the end of when it stops. So we got it. When I put the first iteration as x equal to 1, x equal to 8, x2 came out to be 8.0421, 4 decimal places, that's what they said, and our answer should be in 2 decimal places, so we rounded it up to 2 decimal places. And there were certainly 2 decimal places which were next to each other, which are equal, so we stop the moment we get it. So our answer will be is 8.03, which is between 7 and 9, and this is our answer for this particular iterative formula. Question number 6 is showing us a graph sine 2x 1 plus sine 2x, its minimum point is m. Given that the x coordinates of m lies between half pi and 3/4 of pi, this is 3/4 of pi, maybe this is half pi, find the exact coordinates of m. We have to find the exact coordinates. So what we will do, we know that m is a stationary point. That means the gradient of the curve here will be 0 as well as here. But we will take the value which is more than pi by 2 and then we'll get the coordinates of m. So to find the gradient, which is dy over dx, we'll have to differentiate the given function. So It is sine 2x multiplying with 1 plus sine 2x, so we'll use the product rule where sine 2x will be differentiated first and nothing will be done with sine 2x. 1 plus sine 2x. Then we will keep sine 2x untouched and we'll differentiate 1 plus sine 2x. Okay, so the differentiation of sine 2x will be positive cos 2x multiplied by the differentiation of the angle. Differentiation of 2x is 2, so I'll put 2 here. 1 plus sine 2x. Now sine 2x remains sine 2x. Differentiation of 1 will be 0, so we will not even look at this. The differentiation of sine 2x is again the same what we got at 2 sine cos 2x. Sorry, 2 cos 2x. And that's it. So both of them have 2 cos 2x, we can take it common. 2 cos 2x taken common. So 1 plus sine 2x first. And then in this case 2 sine cos 2x is 2 cos 2x is outside, so we'll be left with sine 2x. So we have 2 sine 2x is here, so it will be 2 cos 2x and 1 plus 2 sine 2x. That is the differentiation of the function. Now they asked us to find this stationary point M. Obviously we'll get two answers from this, but we will select the one which belongs to M between 1 over 2 pi and 3/4 of pi. Alright, so this has to be equal to 0. At stationary point the gradient is 0, so I make it equal to 0. That means 2 cos 2x, either this is equal to 0 or 1 plus 2 sine 2x is equal to 0. So this gives us cos 2x equal to 0. So 2x equal to cos inverse 2x. Cos inverse not 0, 2x 0. So 2x is equal to cos inverse 0 is pi by 2. So x will be pi by 4, which is less than the domain they have given us. So we will reject this answer. This is not our answer. Now this one, 2 sine 2x equal to -1 sine 2x is equal to -1 over 2. So 2x equal to sine inverse -½ but we will write just half because negative, for negative we will just see the quadrant, it will lie. They have given us half pi and 3/4 of pi, which is where it is lying. So if I want 2x, so I'll multiply this by 2. So half pi of 2 will be pi multiplied by 2, and this will be 2x, and this multiplied by 2 will be 3 over 2 pi. So we'll select the answer between pi and 3 over 2 pi, which is third quadrant. And yes, here it is negative. I remove negative to get the quadrant first, and then sine inverse half is 30 degrees or pi by 6. That I will draw with this horizontal line. Okay, so this angle will start counting from 0 and we'll reach here, which is pi plus 1 over 6 pi. Okay, that is 2x. Okay, so 2x equal to 7 pi over 6. And then we can get the final answer from here, which is x equal to 7 over 12 pi. This is the x coordinate of M. X coordinate equal to 7 over 12 pi. Now they said coordinates, that means y coordinate is also to be found out. So y coordinate we can find how? Just substitute it in the main equation, we'll get the y coordinate, which is y equal to sine 2 times x. X is 7 over 12 pi multiplied by 1 plus same sine 2 times 7 over 12 pi. Okay, and what we get here? 7 over 6 pi. Oh, we already got this answer here, which was, it was sine only, right? Yeah, half, which was negative half. So we can put it here. This sine 7 pi over 6 is negative half. This will also be negative half. So 1 minus half is half. So it becomes minus half times positive half, which is negative 1/4, and that makes perfect sense. It is below x-axis. Y coordinate is negative, that's correct. So the coordinates become 7 over 12 pi and negative 1/4. That's the answer. Now, second part says that find the exact area of the region R. And the region R is this. So to find the area under any curve, what do? We integrate. And that's what I'm going to do now. So I'll integrate from 0 to this point. And I'm not sure where is this point. Let me find that point here. So what will I do? I will, because this is the x-intercept, this particular one will get 3x intercept actually if I make y equal to 0 in the main equation. So sine 2x 1 plus sine 2x, this is y, right? If I make this equal to 0, it will give me x intercepts. So this gives me sine 2x equal to 0, 2x equal to sine inverse 0. And now sine inverse 0, if I draw the graph of sine, let me draw where? Let me draw here. Draw pure sine graph is like this. So at 0 it is 0, at pi it is 0, and at 2 pi it is 0, right? So I can place those 3's here and I think I'll get these 3. So let's say 2x equal to, what is the first answer? 0. So x equal to 0 becomes our first x coordinate, that is correct, this one. Second, pi. So 2x equal to pi. So x equal to pi by 2, that is our second, this one. And third, 2x equal to 2 pi. So x equal to pi, which is beyond this, so we cannot look at this. Most probably this one is pi by 2. This particular point is pi by 2, but let me confirm with this that this is not giving me any other answer. So this one, sine 2x equal to minus 1. So sine 2x equal to minus, yes, that means 2x is sine inverse minus 1. And sine inverse minus 1 is where? Where's the graph I drawn? You can see here. Minus 1 is here. So that is 3 over 4th of pi. Sorry, 3 over 2 pi. Yeah, 3 over 2 pi. And if I put here 2x equal to 3 over 2 pi, I get x equal to 3 over 4 pi. Got it. Third one. Then definitely this second point I got was this one, x equal to pi by 2. And for the integration I was about to carry out, I got my second limit, pi by 2. Okay, and now sine 2x 1 plus sine 2x dx. This is what we have to integrate. So let me open this bracket and let me make space here so that I can do it easily at this space. So what will I do? I'll open this bracket, sine 2x multiplied by 1. So my first part becomes 0 to pi by 2 sine 2x dx plus 0 to pi by 2 sine 2x multiplied with sine 2x becomes sine square 2x dx, sine square 2x. Okay, I can integrate this one easily, so I will not focus on this. I will focus on this one. Okay, this I'm carrying out. Once I've done this, then I will look at this first one. Okay, here I will do what? I'll manipulate this. I will write a minus here in front. Okay, and 2 here. That means I have changed something which was not there in the original one. That means this minus has to compensate it. I'll put that minus here. Okay, inside. And I have multiplied by 2, that means I will divide also by 2 outside. And why did I do that? Because I wanted this format, 1 minus 2 sine square theta, this is an identity, equal to cos 2 theta. And this is what I wanted here. I have minus 2 sine square 2x here, but I don't have 1. So what will I do? Obviously, I will put 1 also here, and I'll have to subtract that also. So let me clarify this. What will this become? It will become minus half 1 minus 2 sine square 2x dx. But I compensated this negative with this negative. I compensated this 2 with half, but I did not compensate this 1. That means I'll have to subtract that one also. And actually I did not add this 1. I subtracted this minus here. So minus half I somehow subtracted. So I'll make it positive half dx. That's it. To compensate this 1, it is 1 dx actually, but I'm not adding 1 here. So my equation which I have to evaluate now becomes 0 to pi by 2 sine 2x, which I left, dx, minus half 1 minus sine square 2x, and then plus half dx. Okay, the integration of sine 2x will be minus cos 2x over 2. Okay, minus half, we'll need one more thing here, 1 minus sine square 2x, we'll use this identity, this becomes cos 4x. Why cos 4x? Because the double of theta is 2 theta, so double of 2x will be 4x dx, and then integration of half is just half x and plus c. What I will do, I will integrate this also now. So this becomes minus half cos 2x minus half sine 4x over 4 plus half x plus c, and we have to go from 0 to pi by 2. And I will just substitute this pi by 2 one by one. Okay, minus half cos 2 times pi by 2, 2 and 2 cancel, minus 1 over 8, 2 times 4 are, sine 4 times pi by 2 plus half pi by 2 plus c minus, I'll substitute 0 now, minus half cos 0 minus 1/8 sine 4 times 0, 0 plus pi by 4, 1 over 2 pi, sorry, come on, 1 over 2, 0 plus c. Okay, so I can cancel this c throughout. If you write or don't write, it doesn't make any difference. So let's see here. Cos pi. Cos pi, you can use your calculator. According to my graph, cos pi is minus 1. So minus half times minus 1 will be positive half. 4 times this becomes 2 pi. Sine 2 pi is 0. So 1/8 times 0 goes 0. No need to look at this. Pi by 4, this will be plus pi by 4 minus. Cos 0 is 1 and this minus and minus makes it half. Sine 0 is 0, gone. 1 over 2 times 0 is gone. So this is what we will need here. What will that give me? Half plus half is 1 plus pi by 4. And this is the exact area of the region R, because they said what? Find the exact, not this one, sorry, this one, no, this one. Find the exact area of region R. And this is the area of region R, 1 plus pi over 4. Question 7 is about partial fraction, where you have to express this in partial fraction. So, as usual, we will assume 5x square plus 8x plus 5 over 1 plus 2x over 2 plus x square equal to. First, let's test whether the degree of the numerator is less than degree of denominator. Is yes, it is degree is 2. And here the degree is 3. 1 here and 2 here, total 3. So the numerator has lesser degree, we can proceed. So I'm assuming it a over 1 plus 2x plus b over 2 plus x square. No, because this is degree 2, so I have to write bx plus c here. Okay, let's find LCM of these two, which is 1 plus 2x and 2 plus x square. Now we'll cross multiply, because we have multiplied the denominators, we have to cross multiply here. So a 2 plus x square plus bx plus c times 1 plus 2x. Okay, this will be equal to our original expression, rational expression, plus 5 over 1 plus 2x multiplied by 2 plus x square. Now you can see that the denominator here and denominator here are exactly same, so we can cancel them out. Now here we have to find the value of a, b and c. For that, let's try to make this one 0 and it will make our job easier. So let's assume x equal to minus half on both sides, so that this part becomes 0. Yeah, 2 times minus half will be minus 1. 1 minus 1 is 0. This whole thing becomes 0. So 5 times minus half square plus 8 times minus half plus 5 equal to a 2 plus minus half square, including minus, it will be squared, which is 1/4 positive, right? Since this is becoming 0, so bx plus c and this whole thing becomes 0, no need to go anywhere else. So this becomes 1/4, so 5 over 4 plus 8, not plus, minus 8 multiplied by half is 4 plus 5 equal to a, and this will be 9 over 4. Minus 4 plus 5 becomes 1, and 5 over 4 plus 1 is 9 over 4 equal to 9 over 4 a. Cancel out, a is equal to 1. Now to find b, let's assume x equal to 0. That will make both calculations easy. So 5 times 0 square plus 8 times 0 plus 5 equal to a 2 plus 0 square is 0 plus b times 0 plus c multiplied by 1 plus 0. So everything becomes 0 here. So this is 0, this is 0, only 5 equal to 2a, and this is 0 c plus c. Yeah. So a's value we already know 1, so we'll substitute that. 5 equal to 2 times 1 plus c. C comes out to be 3. So we have a equal to 1, c equal to 3. Left is b. For b, let's compare the coefficient. Let's say compare coefficient of x square. So what is the coefficient of x square on the left side? 5. So we'll write 5 equal to. What is the coefficient of x square in this side? So x square will multiply with a, so a becomes the coefficient. Here bx multiplies with 2x, that becomes 2bx square. So 2b is the second coefficient. So x square I ignored, only the coefficients. 5 here, ax square here, and bx 2bx square here. So that becomes 2b here. Okay. So a we already know. So 5 equal to 1 plus 2b. 5 minus 1, 4 equals to 2b. So b comes out to be 4 divided by 2, which is 2. Got it. But this is not enough. They said express fx in partial fraction. We got a, b and c, but we did not finally write the answer. So let's write finally the answer. So partial fraction is fx equal to a is 1 over 1 plus 2x plus b is 2x plus 3, which is c, divided by 2 plus x square. This is the partial fraction. Alright, hence find the coefficient of x cube in the expansion of fx. So let's do that. So where is our partial fraction? Is this one. We can rewrite this. So we have to write coefficient of x cube only, and that makes our job easy. We don't have to expand everything. Just focus on x cube. So this one, I can write this as 1 plus 2x to the power minus 1. Can't I? This one. And this, the other one will become 2x plus 3 multiplied by 2 plus x square to the power minus 1. Okay. If you know your formula for binomial expansion, it is 1 plus x to the power n equal to 1 plus nx plus n minus 1 over 2 factorial x square plus n minus 1 n minus 2 over 3 factorial x cube plus, and so on. Since they are saying we have to focus on the coefficient of x cube, I will focus on only x cube. Alright. So in this expansion of this, what will I get? X cube will get x cube here because it is perfectly matching with this. Only thing is that in place of x we have 2x. So I'll focus on this. So let me find the expansion of this, only this term, no one else. N is minus 1, then n minus 1 will be minus 1 minus 1, then n minus 2 will be minus 1 minus 2 divided by 3 factorial x cube. In place of x cube, that's the key here, we'll write 2x cube because in place of x in the formula we have 2x. That's what I'm writing here. So minus 1 times minus 2 becomes positive 2 times minus 3 becomes minus 6 over 3 factorial is also 6. 2 cube is 8, x cube is x cube. So they cancel, it becomes minus 8x cube. So the coefficient of x cube in this expansion is minus 8. We have to focus on minus 8, right? Now we will focus on the second term. What we got this was from the first term, now the second one. This 2x has to multiply with x square here so that I get a cube, right? So if I, first of all, this is not in the right term. Let me change this look first. So 2x plus 3 is what it is. But this one, let me write here, 2 plus x square does not match with my formula. My formula starts with 1, it has 2. This 2 must go. So what will I do? I'll just divide both by 2, both the terms, and outside I'll multiply by 2 to compensate this 2. Okay, power is minus 1. That means this 2 I divided here has the power of minus 1 also. So that's what I will do here also, minus 1. Okay, and now my real binomial will be 2x plus 3, which was untouched, times half, because 2 to the power minus 1 is half, and this becomes 1 over x square over 2 to the power minus 1. Okay, now it matches here, 1 here, and x in place of x is x squared 2. Now I want x cube. That means this 2x and x square over 2 will multiply to give me x cube, but if I expand it, so I will expand this now. 2x plus 3, let me write half outside, and the expansion of this, what I need for 2x to be multiplied with something to get x cube, I need x square here, and in this expansion of x we have x square already here. That means this term will give me x cube multiplied with 2x. So I will use this one, nx first. So n is minus 1, x is x square over 2. Okay, now this 3 will also give me x cube if it multiplies with some x cube. But look, if I make x square to the square, it will become x to the power 4. That means I will never get an x cube with the help of 3. There is no cube in this expansion because we have an even number exponent here. It will always be power 2, power 4, power 6, but never power 3 basically. So that is the only one we need. Made our job easy. So I will focus on this. Even 3 is useless for me now. I will not even look at 3. So half times 2x times minus x square over 2 times minus x square over 2. So this 2 and 2 gets cancelled out. We get minus x cube over 2. And now since I have one x cube here, one x cube here, let's see what do we get together. So x cube, let's take it common. It will be minus 8 minus 1 over 2, 16 minus 1, 17. Minus 17 over 2x cube. So minus 17 over 2 is the coefficient of x cube, and I hope that's what they asked. Find the coefficient. Okay, no need to convert to decimal. This is the coefficient. Question number 8a. Z is a complex number, 1 plus yi, and y is a real number. Express the reciprocal of z in the form of a plus bi, where a and b are functions of y. Okay, so now we can say that when z is 1 plus yi, 1 over z will be 1 over 1 plus yi, right? And we want it to be in this format, a plus bi. So we'll have to rationalize the denominator. So we'll multiply this by 1 minus yi and 1 minus yi. What does it become? It becomes 1 minus yi divided by, it will be 1 square minus yi square, right? A plus b, a minus b multiplied, a square minus b square, that's what I've done, which is 1 minus yi over 1, because my I square is minus 1, so it becomes plus y square. And if you want to write it, we can write 1 over 1 plus y square minus y over 1 plus y square I. So a and b are functions of y. So this is a for us, this one a, and minus y over 1 over y is b. So a is a function of y, 1 plus y square. B is also a function of y, which is minus y over 1 plus y square. Okay. B part. Show that a minus half square plus b square equal to 1/4. So what did we get as a? A was 1 over 1 plus y square. So let's see. In place of a, we'll write 1 over 1 plus y square minus half square plus b square is minus y over 1 plus y square. Okay, and we have to show that this is equal to 1/4. We can't use 1/4, we have to arrive at 1/4. Okay, so let's find this one, 1 plus y square times 2. This is the LCM of this, so it becomes 2 minus 2 multiplied by 1 and minus 1 plus y square and plus we can square this one straightforwardly, because this minus y square will be positive y square over 1 plus y square. Okay, since we have opened the right one but the left one is still there, so we can open that as well. So it will be a minus b whole square. That's what the numerator of that will be. Bottom it will be 4 1 plus y square. Yeah, this one, 2 square is 4 and the square of this one. What about the numerator? It will become 2 square plus 1 plus y square minus 2 times 2, 4 1 plus y square, and we got this one as the second part, plus y square over 1 plus y square. Now these two have same part of as denominators. 4 is here, so I can write 4 and 4 so that the denominators become same. So the denominator now is 4 over 1 plus y square. Okay, so now what about this one? 4 plus 1 plus y square. No need to open this because the other part will get cancelled out now. 1 plus y square, and then we have plus 4y square. Okay, if I keep this 4 as 4, then 1 plus y square as 1 plus y square, but I open this bracket only because I can see that they can cancel out. Minus I'll have to minus 4y square plus 4y square over 4 1 plus y square and square. This 4 cancels with minus 4. This minus 4y square cancels with 4y square. So what are we left with? 1 plus y square over 4. 1 plus y square, and again this cancels out. We are left with nothing but 1/4. And this is what they wanted us to show, 1/4. Let's go to the next part. On a single Argand diagram, sketch the loci given by this. So real part of z is 1, is it? Same z, yes. Real part is 1, okay. And z minus half, from half z's distance is half, okay. Okay, so first we have to show that the real part of z is equal to 1. This is real, this is imaginary. Suppose this is 1 here, 1. So our vertical line, this one, is it equal to? Yes, it is equal to. So it will be a solid line. Let me draw a solid line there through this. This particular line is a real part of z equal to 1. Okay. Now we have to show this z minus half. So z minus half, I can write it this way. That means half in real, z is half away from it. So this is half, real half, right? From here, there is no imaginary part. From here, it is half away. So half away is this one, half away is 0 also from this, right? Half away will be here also, somewhere here and there also. So that means there will be a circle which will be joining all these points. Let me join them now. Okay. So this circle is the one where it is equal. There is no inequality. That is only the edges of this circle. This particular part is z minus half equal to half. This circle, not the shaded, not inside, okay? Only this one shows you that one. Where z is a complex number, that's it. We have shown it. This is a z minus half is equal to half. So this is the center. From this half, anywhere on the circumference of this circle is distance is half. Half, 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 everywhere it is half. Okay, this is the drawing. What about the next one? The complex number z is such that the real part is 1, we just saw it. Use your answer in part B to give a geometrical description of the locus of 1 over z. Okay, so this is a particular answer they're talking about, part B, right? This one. And A, if you remember, A is the real part of 1 over z, isn't it? That's what we got, right? A is the real part of z and B is the imaginary part. So in part D, they're saying what geometrical thing it shows. Can I say that the real part of z, right? This A is real part of z, which is 1, yeah? Minus half. From half, we square it then B is your imaginary part. From 0, there is no minus 0, but I am doing it here, is equal to 1/4. Does it remind you of something? It reminds us of distance formula. If I square root this and square root this, and distance formula gives us positive answer, so I'll write 1 over 2 here. That's what they're trying to say here in part D, that real part of z and imaginary part of z, which means the distance or modulus of 1 over z or since they say geometric, so in plus modulo we can say distance, okay? Distance of 1 over z from this real part, which is 1 over 2 plus 0I, right? Or you can write just 1 over 2 is 1 over 2, half. And that's what the drawing is showing, right? So the distance of z from half is half. Question number 9. The position vector of point A relative to origin is this. Okay, so we can say that the coordinates of point A are 8, -5, 6. The line L passes through A is parallel to the vector this one. So if this is the line passing through A, it is parallel to the vector 2I plus j plus 4k. That means this is the direction vector of this particular line. So if it is parallel, this will also have the same direction, 2I plus j plus 4k. Okay. State a vector equation for L. So which will be R. We need a point, rather position vector of that point. It is already given to us. 8I plus minus 5j plus 6k, and then we need some parameter and the direction vector, which is 2I plus j plus 4k. So this much space was not needed. This is the vector equation of the line L. The position vector of B relative to origin is this. Okay, so this is A. Suppose B is here. Okay, and these are its position vector. That means this is the coordinate of B, T, 4 and 3T. Rather it is minus T. Minus T, 4T also. 4T and 3T. This is B. Okay. The line L also passes through B. Okay, so that means B is on this line, not here. This B is here. Okay. Find the value of T. So if this B is part of the line, that means it will satisfy this line, isn't it? So any point on L, the coordinates will be 8 plus 2 alpha, okay, minus 5 plus 1 alpha, and 6 plus 4 alpha. These are the coordinates of any point on this line whose vector equation is this. And since B is on this, that means 8 plus 2 alpha is equal to minus T, right? Minus 5 plus alpha is equal to 4T. And that these two become simultaneous equation. We'll find alpha and T. Rather, they saying find the value of T only, not alpha. So we'll find the value of T. That means we will eliminate alpha from this. That was my creation. And we'll find the value of T. But we will proceed because it's 3 marks. So we can proceed to find alpha also and confirm with the third one that it is actually working and it is good. So let me multiply this whole equation by 2, the second one, so that it becomes rather minus 2. So that this becomes minus 2 alpha and we cancel it out. So it becomes minus 5 times minus 2, 10, minus 2 alpha equal to minus 8T. And then I will write the 1 on top below this. 8 plus 2 alpha equal to minus T. And add them. While adding, they will cancel out. 18 equal to minus 9T, and T is equal to 18 divided by minus 9, which is minus 2. Let's substitute this value of T here. So 8 plus 2 alpha equal to minus 2. So it will be positive 2. 2 alpha equal to 2 minus 8. Alpha equal to negative 6 over 2, which is minus 3. And let's, because only this much you needed to show in your exam, but I'm finding this to confirm that this answer is correct. Okay, so t is minus 2, alpha is minus 3. Let's see if it satisfies the third part, this one. 6 plus 4 alpha, which is minus 3, is equal to 3t, 3 times minus 2. So 6 minus 12 equal to minus 6, which is true. So this part and this part was not needed to be done, but if you have time in exam, always confirm that what you got here is satisfying the third part also. Then only it's possible, because two simultaneous equations will always give you some value. It's not right, it's not necessary that those values are correct for you. Okay, so I just confirmed with this part. Okay, B is done. There is C also. The line M has a vector of, the vector equation is this. The acute angle between the directions of L and M is theta, where theta is this. Find the value of A, and it has A. Okay, so keep in mind that the angle between two particular vectors is A dot B over modulus of A and modulus of B, means the magnitude of A and B multiplied, and this is the dot product of the two. And the dot product is always between vectors, not the points. That means this is the vector point, this one, A I minus j plus 3k. So I will write that one first. So let me write here A I minus j plus 3k dot the direction vector of L, which was 2i plus j plus 4k, 2i plus j plus 4k. Okay, that's what we will do. And they said this is equal to how much? 1 over square root 6. Okay, so let me find this one first. So I'll multiply a with 2a, that becomes the dot product. I dot I is 1, so we don't look at it. Minus 1 times 1 is minus 1. Then we have 3 times 4, 12. That comes out to be 11 plus 2a. Okay, that's the numerator. Now we have to find the magnitude of the first one. So magnitude of first vector, rather, yeah, we can call it A, because L and M are the names of the lines, not the vectors. So it will be A square plus minus 1 square plus 3 square. 9 plus 1, 10 plus A square. Okay, magnitude of B will be 2 square plus 1 square plus 4 square, which is 4 plus 16, 20, square root 21. So let's substitute everything in this equation, this particular equation now. So A dot B came out to be 11 plus 2A divided by square root 10 plus A square, and modulus of B is square root 21, which is equal to 1 over square root 6. To get rid of these square roots, let's square the whole of this and whole of this. So square of 11 is 121 plus 2a is 4a square. Okay, then it will be 11 times 2, 22, 44a. Okay, divided by, when this square will be squared, it will become complete 10 plus a square, and this will become complete 21. This will become 1 square 1, and square root 6, complete 6. Cross multiply. to make it a quadratic. So 726, then 6 times 4, 24, a square, plus 6 times 4 is 24, 264, a equal to 210 plus 21 a square. Let's bring everything to the left side. So it becomes 24 a square minus 21 a square, 3 a square plus 264 a plus 516 equal to 0. And if I factor this, let me factor it here. I get two factors. Let's say a plus 2. You can use any method. You can straight away factor, or you can do one thing. Before that, let's divide this by 3 so that it becomes simpler. So it will become a square plus 88 a, and then 172 equal to 0. And use your calculator or splitting the middle term, you can do this. I'm straight away writing the factors here, which are a plus 2 and a plus 86. So this gives us a equal to minus 2, and this gives us a equal to minus 86. Okay, does it make sense? Yeah. This a can be positive or negative, and so it's possible. That's the answer. Question number 10. A large cylindrical tank is used to store water. The base of the tank is 4 meters radius, and at time t, the depth of the water is h. That means height is variable, but radius cannot. It is fixed at 4 meters. There is a tap at the bottom somewhere here, from where of course water will be coming out. Yes, flows out. That means the volume will reduce once the tap is open. Then proportional to the square root, the water flows out of the tank at a rate proportional. This is important. That means that the water which is coming out, the rate means at the rate which the volume is reducing is proportional to the square root of volume. Whatever is the volume, square root of that, the rate of reduction is proportional to that. That means dV over dt will be equal to k square root v. That's it. So that dH over dt is this. That means the volume should be in terms of height first, so that we get rid of volume. So volume is pi r square h for any cylinder, right? So pi is pi, and radius is also fixed, it's constant. That means it will become pi 4 square h, which is 16 pi h. Now we have to get dH over dt. That means we have to differentiate it with respect to h. Let's do it. dV over dH equal to 16 pi is constant, so it will remain 1. Differentiation of h is 1. That's what it is. So it's constant, 16 pi. Now they want us to have dH over dt. That means we have to substitute this here. Can I change this one also? Let's write here dV over dt equal to k. Obviously it will be negative. Negative. Let's write. Why negative? Because it's reducing. The rate of change of volume is negative. It's reducing. Square root, what is volume? 16 pi h. Okay, that's what dv over dt is. So what will I do in this, the one I did here, I will just divide both up and down by dt. So dv over dt is the numerator now, which is minus k, let me finish it here, minus k square root 16 pi h over dh over dt remains what it is, equal to 16 pi. Now I need dh over dt to be isolated, so this denominator I will cross multiply here and 16 pi I'll bring down. Minus k square root, okay, 16 pi and square root h. I am separating 16 pi and h in two square roots so that it can cancel 16 pi. 16 pi. Alright, so but they did not ask us to find this, right? Where lambda is a positive constant. Yes. So we can see that this is a constant. This one. See, this is a constant. This is a constant. That means all together these three can be called a constant called lambda. So I can write dh over dt is equal to minus lambda square root h. H is the only variable here. Okay, they have not asked us to find. That is the best part. But maybe in the second part they will ask us to find out. Here it is. At time t equal to 0, tap is open. It is given that when time is 0, height is 4. It started with 4 meters and then it reduced 2.25 in 20 seconds. Solve the differential equations. We have to solve this differential equation. So they have not asked us to find the value of k. They are asking us to find the value of lambda in some sense, because they are asking us to solve the different differential equation where we need to have every constant known. Okay. So the first rule of differential equation is that dh should accompany h. So what will I do? I'll bring it like this. dh over h, or square root h rather, equal to minus lambda k dt. Right? Now I'll integrate both sides so that I can get the solution. Okay. Here I can write h to the power minus half dh, right? I just brought this above and converted square root to power half. So when it went up, it became negative, equal to negative lambda and t. Yeah, the integration of dt is t. Integration of h to the power minus half, let me finish here, which will be h to the power minus half plus 1 divided by minus half plus 1 equal to negative lambda t and plus c. Let's write here. Okay. So now we have to substitute the times they have given. When h is 4, time is 0. So what does it become? H to the power positive half, yeah, over positive half. That means 1 over 2. Yeah, that's how we can write it, equal to negative lambda t plus c. Okay, we have to find now these constants, which is lambda and c when h and t are given. So first condition is h is 4, that means 2 and 4 to the power half and 1 you can ignore, equal to negative lambda times 0 plus c. So this 0 cancels it out. So c is equal to 2 times 2, 4. Yeah, we got 4 straight away. Alright. Now second condition. H is 2.25. So 2 times 2.25 to the power half equal to minus lambda, time is 20 seconds, plus c is known to us now 4. So we can find lambda also. 4 goes to the other side, it becomes minus 4. The square root of 2.25 is 1.5 times 2 will be 3. So plus 3 equal to minus lambda times 20. Yeah. So minus 4 is minus 1. minus lambda times 20. So lambda is 1 over 20. Okay. Hence find the time taken to empty the tank. That means volume becomes 0 or height becomes 0. Alright. So what does our equation become? What was our equation? This was the equation. This was the equation, right? 2 square root h. Let me change the color. 2 square root h, that is the one, this one, equal to minus 1 over 20, which is lambda t plus c is 4. Okay. What are they asking us? Solve differential equation, obtain expression, done. Obtain the expression, this one. And then they are asking us to find the time taken to empty the tank. That means height is 0. 2 square root 0 is equal to minus 1 over 20 t plus 4. I'll take 4 to the left side. This has become 0, so 4 becomes minus 4 equal to minus 120 over and t. Cross multiply, it becomes 80 equal to t. 80 minutes or seconds. They have not given a unit. So t equal to 80. This is the time when the tank empties. This concludes my solution video for this year 2024, October-November 2024. If you liked it, please show it by giving it a thumbs up, share this video with your friends and subscribe to Math United. Thank you very much.